Today we're going to be reading chapter 27, section 1 on page 711. Populations and the use of natural resources. Suppose you and some of your friends plan to spend a day at the park. Some of your friends start a volleyball game, while others unpack the cooler and light the barbecue. Later on, maybe all of you will go for a bicycle ride. Did you know that each of these activities you and your friends would be using natural resources? Resources and organisms. Take a deep breath right now, then let it out. When you inhale, you take oxygen gas out of the air and into the cells of the blood vessels in your lungs. When you exhale, you release oxygen and carbon dioxide gas and water vapor back into the air. Oxygen, carbon dioxide, and water are examples of natural resources that you, as well as many other living things, use every day. Like all organisms, you need particular natural resources to maintain life, grow, and reproduce. Among the resources that organisms require are air, food, water, and, in some cases, shelter. To meet their basic needs, most organisms are adapted to their immediate environment. They live in a balance with the natural resources their environment provides. For example, songbirds live in grassy meadows, forage for grass seeds to eat, weave nests out of dried grass and twigs, and drink water from ponds or streams nearby. Painted turtles live in ponds, swamps, and slow-moving streams where they eat aquatic plants, insects, and other small animals. Other organisms, however, alert their environment to better meet their needs. For example, beavers build dams across streams to create ponds where none previously existed. Such alterations of the environment have both positive and negative impacts. It kills some trees and it displays both aquatic and terrestrial organisms, but at the same time, it creates a new wetland environment for other organisms. Termites in tropical areas also create environments that are favorable to themselves. By building tall mounds, both a beaver dam and a termite mound, shown in figure 27.1, alter the environment to provide for basic needs of the organisms that build them. Many of the other organisms alter their environment to improve their chances of survival. For example, corals build huge underwater reefs that provide homes for all kinds of marine organisms. Of all the organisms, however, humans have an unequaled capacity to modify their environments. This capacity allows us to live in very terrestrial environments on Earth. As a result, humans also have the greatest impacts on Earth's natural resources and population growth. Any type of organism can have an impact on its environment. If its population becomes large enough, for example, your consumption of oxygen and release of carbon dioxide usually has little effect on your immediate environment. However, if you were in a closed room crowded with people, there would soon be less oxygen and more carbon dioxide than the amount of people are used to. If no additional fresh air entered the room, everyone eventually would become uncomfortable and would leave the room. As any population increases, its demand for natural resources increase as well. Figure 27.2 illustrates what happens when an elephant population exceeds the ability of the environment to provide the necessary natural resources. Population growth is defined as an increase in the size of population over time. A graph of a growing population resembles a J-shaped curve at first. Whether the population is one of dandelions in a lawn, squirrels in a city park, or herring gulls on an isolated island, the initial increase in the population is small because the number of adults capable of reproducing is low. As the number of reproductive adults increases, however, the rate of population growth increases rapidly. The population then increases exponential growth, a pattern of growth in which a population grows faster as it increases in size. As shown in figure 27.3, exponential growth results in a population explosion. Limits to population growth. If the graph in figure 27.3 was extended for a long period of time, what do you think would happen to the size of the population? Would it continue to grow exponentially? Many of the Earth's natural resources are in limited supply, and therefore most populations cannot continue to grow forever. Eventually, one or more limiting factors, such as the availability of food, water, or clean air, will cause populations to stop increasing. This leveling off of population sizes results in an S-shaped curve similar to the one in Figure 27.4. The number of organisms that any given environment can support is its carrying capacity. When population size has not yet reached the carrying capacity of a particular environment, there will continue to be more births than deaths. If the population size exceeds the carrying capacity temporarily, the number of deaths will increase, or the number of births will decrease until the population size returns to the carrying capacity. A population that is in the carrying capacity for its environment is in equilibrium. It comes to fluctuate around the carrying capacity as long as natural resources remain available. Environmental limits. Have you ever seen television or newspaper coverage by the aftermath of a tornado or other violent storm? Storms are environmental factors that limit population growth. Environmental factors that affect population growth, such as storms, extreme changes in temperature, droughts, floods, and population, are density-independent factors. These factors affect all populations that they come in contact with, regardless of the population size. A flood affects not only the humans whose homes are destroyed, but also trees, birds, and other populations of organisms. Other environmental factors that affect population growth, such as disease, parasites, and lack of food, are called density-dependent factors. Density-dependent factors increasingly affect a population as the population size increases. For example, in a large population, members may live close together. This enables disease organisms to spread quickly from one member of the population to another. If a population is very dense, disease may wipe out the entire population. Human growth population. No matter where you live, you probably have seen an increase during your lifetime in the number of cars, houses, and roads. The human population on Earth is still growing. As shown in Figure 27.5, the growth curve of the human population is still in the J-shaped stage. The human population is expected to continue to grow for at least another 50 years. Although the human population has not yet reached the carrying capacity of Earth, the current rate of growth clearly cannot continue forever. As the population continues to increase, human demand for natural resources also will continue to increase steadily. Although humans are not the most abundant species on Earth, our use of natural resources has impacted the environment on a global scale.